Applications of Trigonometry. Please make sure you guys get down your goal. We are still looking at your laws of sine and cosine and SOHCAHTOA to apply to real-world problems. And we're also going to take a look at area as well, because area is also a part of the trigonometry. We're going to look at the area of a triangle, area of any type of triangle. And we're going to start there. Say again. One more time. I didn't hear the first part at all.
Is it Euler's equation or
Herons. That's another way to find an area of a non-right triangle. Herons. Yes. You have your basic equation for to find the area of a triangle. What is the formula for the area of a triangle? 1/2 base times height. This is only applied to right triangles or triangles that have a perpendicular height to a respective base. Okay. You also have Heron's formula. Let's say that you were given all three sides of a triangle. Heron's formula was the formula that allowed you to find the area of that triangle. Okay, where S represented 1/2 A plus B plus C, and actually that's wrong. I'm trying to remember from my memory box. Okay, you have this, all right, but the one formula that you really need to know when it comes to finding the area of a triangle is not your most basic 1/2 base times height, even though that's always good if you do have a right triangle. Definitely not Heron's because it's too much extra stuff that's in there that you have to remember, but your formula here. The area of a triangle is half the product of the two sides and the sine of the included angle. So if you're given two sides of a triangle, even if you're given all three, if you know the included angle between any two sides, you just take half the product of the two sides and multiply it to the sine of the included angle. So in this respective formula, as you can see, you have two sides and an included angle. So then you do half the product of the two sides. So product means multiplication. 11 times 15. Then you multiply it to the sine of that angle. And that's how you find the area of your triangle. Even if you were given three sides, even if you were told that this was 7, you still would take the two sides that are surrounding the included angle to find your area. And have you guys figured this out? What's the area of the triangle? 38.7? Yes? Yep. Don't forget your units, so let's be 38.7 centimeters squared. Okay, now this is very basic, very straightforward. However, it can be used in an application problem later on. But again, 1/2 AB sine C, 1/2 BC sine A, 1/2 AC sine B. Your two sides times the sine of your angle divided by 2. Questions? All right. So let's look at these application problems. It's going to incorporate right triangles. It's going to incorporate non-right triangles. It may incorporate area. But let's just go. So a triangle has two sides with the lengths 10 centimeters and 11 centimeters and an area of 50 centimeters squared. We're going to determine the possible measures of the included angle, and we're going to give our answers accurate to 1 decimal place. So in some triangle, two sides, it doesn't matter what two sides, are 10 and 11, and the area of the triangle is equal to 50 centimeters. So in this particular case, to find the angle of the included angle, we're clearly going to use 1/2 your two sides times the sine of your angle. And since I don't know what my angle is, that's what I'm looking for in the problem. And all this should equal what? 50. It should all equal 50. Okay? Now, because I am looking for an angle, that means at some point in time, I'm going to have to do what? The inverse. So go ahead and find what angle theta is. What is theta? And so you guys have to be careful. It told you right here, it gives the possible measures. That means there's more than one. Why is there more than one in this particular case?
Because it could be angle side-side.
Because this could have been an side-side angle situation where you have the ambiguous case. So it could be 65.4 degrees, or it could be its supplementary angle, and that's what you get when you subtract that angle from 180. What is that? 1 decimal place is what? 0.6. And you can always, of course, check by plugging in both angles into your formula, and you'll see that both of them give you 50. Real quick, can you plug in both of those angles to confirm that it gives you 50? They both give you 50?
Yep.
Okay. Let's look here. A rectangular prism has the dimensions shown. You're going to find the measure of ABC. Now, a rectangular prism means that every edge of that prism intersects to form a what? A right angle, okay? Every edge of that prism is going to intersect to form a right angle, okay? The only ones that don't are the ones that you draw in yourself, okay? So, like, if I'm trying to go from, like, A to B or something, you know, I'm creating different angles and stuff like that. So I'm trying to find the measure of angle ABC. So I'm trying to figure out that angle right there. Okay? Now, since A and B lie on your diagonal plane, but then C lies on a different plane, we're actually going to have to create our own triangle, like so.
So if that rectangle was a block right in front of us, that triangle would be slanted just like that.
Say it one more time.
Okay, so if we took that 3D rectangular prism and that was in our hands right now, that triangle would be like this, pretty much. Okay.
So how can I find this angle right here? Get off of that. Dan?
I see. If you're gonna find AC, you use the Pythagorean theorem, right? Okay.
If I'm trying to find AC, I would need to use Pythagorean theorem with what?
11 and 6.
With 11 and 6, okay? So Pythagorean theorem. So to find AC, which is the hypotenuse of that triangle, AC squared equals 6 squared plus 11 squared. AC is equal to 36 plus 121. AC squared is equal to 157. So AC is the square root of 157.
It's 12.03.
Some decimal. Okay. Now, considering that I need to use that in this problem, I'm not gonna use the decimal. I'm gonna use that simplified radical, or not even the simplified, just the radical itself.
Wouldn't C be a 90-degree angle?
Would C be a 90-degree angle?
Because yes,
Wait.
if it runs along this plane over here and it runs like this,
Yeah, you know.
that's 90.
Oh
Definitely
wait,
90.
it's leaning.
Yes, because one of the sides is a side on the actual prism, it does create a 90-degree angle with that opposite vertex at A. So this is a 90-degree angle here. So then to find angle B or ABC, I would need to use what trig function? Tangent of ABC is equal to
Root 157 over 14.
157 over 14. Again, we're using the square root number because we, instead of trying to carry the decimal through, it's a little easier. And because I'm looking for an angle, I'm going to have to do the inverse. So tangent inverse of the square root of 157 over 14 is equal to what? 40 what? 41.8. Questions? Keep going. When Samantha is jogging or goes jogging, she finishes 2 kilometers south and 3 kilometers west from where she started. Again, we're looking at compass points here. Okay? North, east, south, west. Okay? So wherever she has started from, she finishes 2 kilometers south and 3 kilometers west of where she started. So wherever she started, she went down 2 kilometers, and then she went west 3 kilometers. South and west form what kind of an angle?
90.
A 90-degree angle. So here we have a right triangle. Now it is asking us to find Samantha's bearing from her starting point. Now I talked about bearing the other day.
It goes north and then it goes clockwise.
So from the north direction, it does go clockwise. So from the north direction, the bearing would be this right here. Okay? Because this is technically the path that she actually ran. So this right here is the path she actually ran to finish here.
And that angle on the top is 45, right? Because you're going southwest.
We're not going exactly southwest because
it's 2 km and then 3 km.
exactly. Now this was 2K and 2K, then yes, we could say this is 45 because it's not isosceles right triangle at that point. But we do need to figure out what this angle is on the inside of the triangle. So then that way, to find the actual true bearing, we'll add it to 180. So go ahead and find this angle. And then once you find the angle, you're going to add it to 180 to find the bearing. What trig function did you use to find theta? Tangent of theta equals what over what? 3/2. So you had to do the inverse of tangent of 3/2 to find theta. What was theta? So then you had to add that to 180. So your bearing is what? 236 degrees. Remember, bearings always written in 3 digits, 3 figures. And so make sure that if you are missing, if it's a double-digit number or a single-digit number, you have the 0 placeholders in front.
Why is it always 2 digits?
That one I don't know. But I guess it's to differentiate between longitude and latitude numbers. For this one, I want you guys to try to draw the picture first before we try to actually find A and B. But it says a courier departs from depot A and drives on a 136-degree course for 2.4 kilometers to an intersection B. He turns right at the intersection and drives on a 226-degree course for 3.1 kilometers to his destination C. Before we find part A and part B, I want you guys to draw this picture. Where does he start? He starts at some point A, right? Then he drives on a 136-degree angle course for 2.4 kilometers to B. So, this is a bearing, which means that from your north direction, heading
Southeast. Oh, it's southeast.
southeast, basically at a bearing of 136 degrees, he's heading to point B. So this angle right here is 136 degrees. Did you guys have that in your picture? On top of that, you can put that this is 2.4 kilometers. That's how far he went to get to intersection B. Now, once he gets to B, he turns right at the intersection, then drives on a 226-degree course. Again, that's another bearing. Remember, bearings come from a northern direction, heading which way? clockwise. This time is for 226. Now 226 is more than 180 degrees, so it's almost like he's heading in the southwest direction. And then this is 226 degrees for 3.1 kilometers to C. Questions so far? Now, the question is asking us to find the distance between A and C. So we're going to be looking for this red segment right here. This creates a triangle. Inside the triangle, we don't have any angles yet. But we can actually figure out what angle ABC is. And it uses an old geometry concept. In order to find this angle right here. Huh?
That's just a right angle, right?
How do you know?
Well, parallel lines and.
What about parallel lines?
Okay, so the one A and B, they're connected to these parallel north lines.
Correct. Parallel north lines.
Yeah.
Well, we don't have any alternate interior angles here because even if we continue the north direction down, we're kind of.
Well, if you took away the difference between 226 and 180, you have that right angle from the right there, and then you subtract that from 136, and you get that.
I just said 220.
That is true. So if I extend this out, then this angle and this angle, the two orange ones, they are both 130. Yeah, they'll both be 136. And so, yes, we can subtract 180 from 226. What is that? 46?
Maybe 44.
180.
Oh, okay. Sorry, I'm different numbers. I'm thinking too hard.
Happening.
All right. So then, since those two angles, the 46 and then the angle inside the triangle that we want, have to add it to be 136, this will be 90 degrees. Good stuff. So yes, this is a right angle. Another way you could do it, don't forget, outside of alternate interior angles, you have those two. What are those called? Not corresponding. They were consecutive interior, same side interior, and they were the only ones that were supplementary. So if that's 136, that angle was 44. And together, they make a 360 degree circle. So 44, 226, the remainder has to add up to be 360. It's another way you can do it. But nonetheless, this is a 90-degree angle. Go ahead and find AC, and then also find my bearing of C from A. So, to find AC, the distance of A from C, this is a right triangle. And so, if we know two sides of a right triangle, we're trying to find the third, we use Pythagorean theorem. Because we have the two legs, and we're looking for the hypotenuse. And so, we're going to take the square root of 3.1 squared plus 2.4 squared to get what? Say again. What is that? Like the answer. Anybody get AC? 3.92? 3.92 kilometers is AC, the distance of C from A. Now that wording is very interesting because it does say of C from A.
So you have to do 180 plus angle C.
Not quite. I mean, you probably could. But wait, hold on. You want to be careful on which bearing you're trying to find. Because it says of C from A, that means that if I started at A and I went directly to C, it's asking for that bearing.
Oh.
That was the thing. From A basically told you if I'm coming from A and I wanted to go straight to C, what's the angle that he could have turned to basically go just directly from A to C. So we need to figure out what this angle is to get our bearing. Now we already know that part of it is 136, so if I can figure out this last little bit, then I just add it to 36. So then this would be tangent of theta equals 3.1 over 2.4, and then whatever theta is, you add it to 136 to get your bearing.
52.
So then I add 52 to 136?
Yes.
What do you do?
What do you do?
Wait, hold on. When you find theta, you're finding this whole angle right here.
Yeah.
What was theta?
56.
56? So then you add
Oh, sorry, 52.
52.
Sorry.
So then you add that to 136 and you get
I got
188.
188.
Okay. I kept hearing y'all say 180. That's why I was like, that's not right. So 188. 188 degrees. 188 degrees.
Where are people like 56 when I go?
All right.